So today we'll do the decision tree. Okay, logistic regression we have done. Decision tree we will do, and after that we will do support vector machine and Gini rest neighbor and all this. Let's do the decision tree today. Yeah, so decision tree are popular supervised learning algorithm used for both classification and regression. They model decision in the form of tree like this. Wait, decision tree. Let me show you. So according to your data, your rows, it will make something like this. Okay, like this. Right. This is understanding the risk of to prevent the heart attack. So root node, you can say the age is there less than 18, 18 to 30, 30 above. So all the trees you can see, it is made using the data. This kind of tree it will make. Okay, whenever you use data. So they model decision in the form of tree structure where internal nodes represent test on an attribute feature, branches represent the outcome of test, and leaf node represent the final output. Key concept of decision tree. Sai Babu, are you sleeping and taking classes? Where is your laptop? Key concept of decision trees. Root node means this top node. Internal nodes means all these weight, smoker, these are internal nodes. Leaf nodes are the terminal nodes like low risk, high risk, low risk, high risk. You can see the output. And branches are the node which are bridge which is connecting like this. How decision tree work? So split the data set. First of all, at each internal node, the data set is split based on the value of a feature. The split is done to maximize the homogeneity of the resulting set based on the measures such as Gini impurity. So Gini impurity is like we can say, let me show you something. See, for Gini impurity, I have one example here. You can see that this is particular party B and this is particular party C. Okay. So, and this party is saying that I will pass, whenever we will win, I will pass this A bill in the government. And so you can say that 70%, 78% people are supporting it, 32% are not supporting. Okay. And this is a particular party B. Uh, for the bill, support people are 98 and those who are not supporting are 2. So who will think will win the election? Particular party C or B? Okay, B, yes. So basically you can see because there is a lot of clarity here in the audience, right? There is a lot of clarity in the democracy. 98% are like they're very clear with the decisions, right? That's why clarity is very high, and the impurity of this party is very low. Impurity means there is no confusion, right? So this is called Gini impurity. When the impurity, when the confusion is very less. Impurity means confusion. So it is used to find a confusion parameter. Whoever will win the whoever will be less confusion, that node will be on the root node on the top, like this. Okay. Suppose you have three features. Yeah, so B party wins, so that's why it's on the top. C have some confusion, that's why it is internal node. Okay, that's Gini impurity. Okay, what is entropy? Entropy used in information gain measure the amount of uncertainty in a set of example. Entropy is like you can say here there is five white balls, six white balls, and one green ball. So if I pick up one ball and if it is white, will you be surprised? Yes or no? Will you be surprised if that ball is white? If I pull out one ball, no, maximum or a white probability of occurrence is more white. No, yes. So for white, you will be not surprised, but for this green, you will be surprised, right? It will be surprised as very less chances. Yes, right. Okay. So this entropy is the parameter of finding the surpriseness. They call it uncertainty. Okay. So you can say the probability of white is very high, 6/7. That's why it will be not so much surprising. Like you can say it's just a reverse. The entropy and surpriseness is just reverse of probability. More probability, less surpriseness. More surpriseness, less probability. Okay. So if we talk about the formula, I will talk about the formula. Wait. So you can see the formula of entropy is minus summation of pi log 2 pi. It means where pi is a proportion of class. Pi is a proportion of class. It means your entropy formula is the probability, okay, the probability versus quantity. How much in numbers it is and its probability. This is a formula. So they write it in this way minus summation of pi log this. So this one is the you can say proportion means quantity, and this thing is telling us the probability. Okay, this is how we find the entropy. Okay, then we have variance reduction used for regression tasks. Measure how much the variance is reduced after the split. So variance is like you can say just a parameter used for regression task. You measure how much the variance is reduced. So basically, there is a lot of reduction whenever we use split the, suppose variance here is 100. If you split it, it might split into 50-50. So there is some reduction. This is how, this is variance reduction. Okay, what is repeat recursively? The process of splitting is applied recursively, resulting in a tree structure where the internal node is a decision point. Yeah, each internal node is a decision point. Okay, so when we have, you have to stop making that tree. Like if you are keep on making a lot of nodes, when you have to stop. So all the data points of the nodes belong to the same class. For example, this after weight less than 60, greater than 60, you don't have any other option. So you have to stop here. The maximum depth of the tree is reached. Like you don't have much data now. There are no more attributes left to split on. You don't have any other feature or column you can say to split. How to make the prediction? So the data is passed to the tree following the decision rules at each node until a leaf node is reached. To make prediction, the new data is passed through the tree. So like you can pass a new row and you have to follow the tree to get the answer. Suppose if they are asking about a person whose age is 15 and his weight is 72. So tell me he's at a high risk or low risk? High risk or low risk? This is a data, raw data. Yeah, tell me. 15 is age, 72 is weight. High risk, yeah, correct. High risk because if you follow this, it will go from here. Less weight is high risk. So you are reaching here. Correct. So the formula of Gini impurity is 1 minus summation of pi square. Means p is the probability of a class. The probability square. summation of all the probability of the particular. I will discuss it how to do it, but this is a formula of Gini impurity. Okay, what is the formula of information gain? So like information gain, you can say you can say it is a probability of whole one group of node. Information gain. How to calculate this? So if you have entropy of parent, it means this one minus number of sample of child node upon number of sample in the parent node. I will tell you how to calculate it, but this is the formula. Okay. Okay. Let's do an example. Very fast. Okay. One for weather, I will calculate the Gini impurity and all this. For temperature and windy, you have to do it. Okay. So we have data, weather, temperature, windy, and according to that, you will decide whether you go to play outside or not. Okay, so suppose it is sunny and the weather is hot and there is no wind. Will you go to play outside? Yes or no? No, right. No. Then sunny, mild, windy. Yes, will go. This is the data or data. Okay. Okay. So now what we have to do, you have to figure out like which among these three feature which will be on the root node here or which will be on the internet node. So you know that here there will be only one feature which has a low impurity, right? For who is having less confusion, low impurity, that will be on the top, right? Okay. So how we can decide which feature it should be on the top? So for that, let's analyze this weather first. Decision tree process. We want to build a decision tree to predict if you will play outside based on this condition. We want to build a decision tree to predict if you will play outside based on these conditions. Starting point. The decision tree begins by checking the most important feature, the the one splits the data most effectively. So that we will put on the root node, who is splitting the data more effectively. Let's say the first feature to check weather is weather. Okay, so in weather, you have 3 points like first is sunny, then cloudy, then rainy. There will be yes, there will be no. There will be yes, no. Yes and no. You have to count. Okay. So splitting the weather. The weather is sunny. We check the next feature. The weather is cloudy. So you have to compare this now this row and this output, how directly it is affecting. Okay. So every weather has yes, no, yes, no, yes, no, which is the outcome. Okay. So what you will do? So okay, let's calculate it. The Gini impurity of this particular. So watch your data and tell me if it is sunny, the person will. If it is sunny, the person will. How many yes and no for the sunny? Sunny is there, sunny is there. Two sunny. One is no, one is yes. It means for sunny, one we have no, one we have yes. For cloudy, how many yes and no? Tell me. Two yes. Okay. Yeah, correct. 2-0. For rainy, 1-1 is right. Apply the formula of Gini impurity. So for particular this one, apply the formula for particular this one first. So it will be 1 minus, because this is the probability of yes in the sunny is 0.5, which is half, because there is 2 and among 2 there is 1, 1 by 2, which is half, and for this also it is half, what 2 0.5 for this. Apply the formula, so it will be 1 minus the square of this, right? Because the formula of Gini impurity is p square 1 minus p square, right? This is the formula of Gini impurity. This is how we do this. So we do this and we find out the Gini impurity of the whole sunny is 0.5. Okay, let me delete this. Whole particular this node is 0.5. Same you will do for the next one, cloudy. If you calculate a Gini impurity like this formula, put the, because 2 is 100% and no is 0%. So if you solve this, it will you get there is no impurity, purity. It's pure. So zero impurity here. Here half impurity is there. There is zero impurity. And for this also you will find that it is half impure. Okay. So for weather, you have calculated, but still after rain, yes, still you have to calculate for the further. Like how much is the, now we have to Gini impurity for each groups and we calculate the weighted Gini impurity for entire split based on the weather. So now we will find for the entire weather. This one. So you apply the Gini impurity here now. So number of sunny upon total yes no, number of cloudy total. So if you apply, so you will find out that it is 2 by 6 multiplied by the Gini impurity of particularly as sunny plus the probability, you can say the probability of cloud multiplied with the its impurity, probability of rainy and Gini impurity of rainy. So after doing this, you will find out that the whole impurity of that particular weather is how much. After solving this, how much it is? 0.33, which is, you can say, this is Gini impurity. How much impurity it is? It is almost one third impure. Lot of impurity is there. Okay. Same way you will do for the same way you will do for the okay. Can somebody calculate the Gini impurity for the temperature now, please? Please calculate the Gini impurity of temperature. Compare directly with this. You have hot, mild, cold. Three options here. Please calculate and tell me. First of all, calculate for each single one and then calculate a total one. 0.33, but have you calculated it? For temperature, how much it will be? Hot, cold, mild. So for hot, how many yes? How many no? How many yes? How many no? Hot, 1 1. Okay. Hot, 1 1. Yes, yes. Cold, 1 1. Okay. Mild, 2 0. So I think the Gini impurity of this will be again 0.5, 0.5, and 0 here. So if you do the total, I think again you will get a 0.33 because it's same like the previous weather one, right? So both are same. Okay, now what's windy? What's for windy? Windy is two types only, yes and no. And within this we have yes, no, yes, no. How much? Okay, for yes, two yes and one no. Okay, for yes, yes, one no, two yes. Okay, for now for no, two yes, one no. If you follow this 2 by 3, 2 by 3, what is 2 by 3? 2 by 3 is like 66%. 0.66 square, 1 square. How much it is? Okay, 0.44. Okay, fine. Okay, 0.44 for this and this both, right? 0.44 for this one, 0.44. Or this 0.44 or this and for this. Okay, now calculate for the whole. For yes, how many years are there out of 6, 3? So I think this will be the same here also for no also. So you can just multiply it for 2 times. No, how it can be? Wait, if you cut down, this is 2, 2, cut down 0.4. Okay, 0.44 for whole. So I think, what do you think now? There is the Gini impurity for this was 0.33, 0.33 for this, 0.44 for this. Impurity. Who is more pure? This two. This one pure. This is pure. This is fourth one. Wind is impure. Third number. Right? That's why weather should be on the top. And then you should have temperature. After temperature, you should put your windy. Okay? This is how you should follow. Okay, so the Python code is here in front of you. Import all the libraries. I will not waste time here because I have to give you one data so that you can test. We are working on the iris data. Most of you people already know iris data, I think. Petal length, petal width, sepal length, sepal width defines the three flower. So we training on the features, trying to get the flower. Our criteria of descent tree will be Gini impurity, maximum depth, like because we have three features, so 3 level it will make, and then you can fit it, predict it, and then even you can print your tree what your model made. You can print a tree. Let me print this. Right. See, it will print a tree like this. Petal length was very important, so it's kept on the top. So gain impurity of this is 0.66. See, they are putting the impure a lot on the top. Maybe because that may be splitting the data very nicely. Maybe that's why. But the Gini impurity of this petal length feature is very high here, 0.66, and then petal length 0.5, then petal width is 0.05, which is very less impure. By the way, they are just doing reverse, like they are putting the more impure thing on the top. Petal length, petal width, sepal length, sepal width. These are four features. So they are using it here. If it is less, if the flower have length less than 2.4, it will go here. Otherwise, it will go here. Then they are checking. Okay, if it is going left, then it will be definitely the flower will be setosa. No confusion. But if the length is greater than 2.4, there is two possibility again. it could be versicolor or virginica. For that, they are putting the petal length. If it is less than 4.7, then it could be this flower versicolor, otherwise it could be virginica. But uh, so yeah, based on the versicolor, they are making some decisions. So if the length is more less than 4.7, it could be it could be any flower among versicolor virginica, but you have to see the length also now. So petal width, you will see petal width here. And if it is greater than 4.7, you will go here, check further petal width again. If petal width is less than 1.65, then you will say it's for sure versicolor, otherwise you will say it's virginica. And here also you will check with less than 1.75, it could be versicolor, otherwise it is virginica. If you see this, there is some values here. Wait, let me show you. This one, values. These values are for the Satosa, versicolor, virginica, right? So there, this is for 40. Out of 120, 40 votes are for Satosa, 41 is for virginica and versicolor, 39 is for virginica. So among 40, it is splitting again for the three flowers. Now you will see that all the points gone for the Satosa. That's why Satosa ends here. But if you see 41 plus 39, which makes 80. Among 80, 41 goes for versicolor, 39 go for, yeah, 41 gone for, you can say here, versicolor. You can see the class name, and 39 gone for the virginica here. See, this is how it divides. Okay, data is in front of you, code is in front of you. I'm giving you one data. Okay, which is heart disease data. Yes, use this data and tell me. Use this data to train your model and tell me how it is performing. So age, sex, chest pain, resting blood pressure, serum, cholesterol, fasting sugar, everything you have. So what you have to predict here, the data set names consist of four database of people and including the predicting value, but published experiment 14. Target field refers to the presence of heart disease in the patient. So you have to tell whether the patient has the heart disease or not. 0 means no disease, 1 means disease. Wait, I think there is one problem here in this uh, data. Let me see again. There is no outcome, right? Whether in the data, yeah, in the data we don't have the outcome, like whether that particular person had a heart disease or not. Like this data is not telling us. I think Indian diabetes, this data you can use. Okay, let me open this. Oh, wow. This is very messed up tree. But I think, okay, let me use this data. I think maybe they have not given the target. Okay, you can try this diabetes data. Here you have the outcome at the end. See whether the particular person has a diabetes or not. Code is here in front of you. Okay, with this data, I cannot see what is written. Can you send the screenshot with the full? I think this is divided very fine, but this much big tree. One, two, three, four, five, six, 7, 8, 9, 10, 11, 12, 13, 14. How many levels are there? 14 levels. Oh wow, Abhishek, you have a great evening, huh? Sitting and just having a sip of tea. Amazing. Data science with tea. Okay, yeah, Nikhil try to like, sir, I think I need to make changes in the figure size. Yeah, do something and try to play with this maximum depth. Try to increase or decrease, right? What is the accuracy, by the way? Is it classifying very nice? 75, wow. 75 is fine. 0.7, yes. Okay. 75 is fine. Okay, we should not go to the figure. Working fine. In future, some algorithm it will improve a little bit. Okay. You must have noticed that it is good performing than the logistic regression. Decision is performing very nice. All right. So the next session we'll do the support vector machine and k nearest neighbor, k means all these. All right. So have a good day. Bye bye. See you soon. Meet you next.